This is Mr. McCord's ICP class, Unit 5, assignment number 1. We're going to be looking at ionic bonding. So where we kind of left off in Unit 4 was that atoms can sometimes get rid of electrons or pick up electrons. They gain or lose electrons in order to become a little bit more stable. So we talked about how an atom can have a full set of valence electrons, which is typically 8 valence electrons, VE for valence electrons, okay? Or they can empty out all those valence electrons, all those outer electrons, to get down to 0 valence electrons. So we hit on how an atom can become more stable by either gaining electrons to reach 8 valence electrons or losing to get down to 0 valence electrons. But there's a little bit more to it than kind of where we left off. So when an atom gains or loses electrons, when it gains electrons, it becomes negatively charged by having those extra negative electrons. When an atom loses electrons, it's going to become positively charged. And positive and negative charges attract each other. It's what kind of holds the atom together. So what happens when you start having ions that are positive charged and negatively charged near each other? They're going to start attracting to each other. Okay, so the story doesn't end after an atom gives up electrons or takes in more electrons. There's going to be something that happens as those atoms get closer to each other. They can become even more stable, even happier, even more comfortable, okay, by following that attraction by a positive ion, a cation, going out and finding a negative ion, an anion. And it's actually even more connected than that. If we think about it, an electron is an awful thing to waste, to just pitch off out into the darkness, the void of the atomic world. And also, if an atom is going to go gain an electron and grab it from something, where is it going to grab it from? There's no electron store. It can go walk in and just buy it, drop a couple bucks on the counter and grab an electron. So the way that atoms give and take electrons actually has a lot to do with how they come together and how they end up attracting each other as they give that give and take. They become positive and negatively charged as they become ions. That attractiveness that connects those atoms is called a bond. In this case, it's coming from ions, so we call it an ionic bond. So in this video, we're going to see how we make ionic bonds between ions, how those ions form and how they end up attracting to each other to make a compound, a substance made of a couple different elements, at least 2 different elements. Okay, so the first compound we are going to make is between the elements sodium and chlorine. Okay, so we're going to look at sodium first. We're going to see how these end up bonding together. So if I want to figure out how these attract to each other, I need to figure out how they become ions. Otherwise, we can't really make an ionic bond or an ionic compound without ions. So sodium, if we go look on the periodic table, is in group 1. It's in the alkali metals, which means it has 1 valence electron. So it's starting right here, which means it's going to be way easier to lose that 1 valence electron than it is to gain 7 valence electrons. So sodium, Na, is better off losing that 1 valence electron. Okay? So we know that much for sure. To stabilize as an ion, sodium, Na, must lose 1 VE, 1 valence electron. Okay, that gets it down to 0 valence electrons. It totally gets rid of that valence energy level, where that kind of outer edge of the atom is, where it has those electrons. Okay, it becomes a cation. That means it's positive. Cations are positive. Okay, and how much positive charge is determined by how many electrons we lose. Okay, so if we are just losing 1 negatively charged electron, remember that flips. So we go from having a neutral atom to losing 1 negatively charged electron. That becomes a positive 1 charge. Okay, so our sodium is going to wind up losing 1 valence electron to get a positive 1 charge. This is nothing new. This is something we saw in Unit 4. Okay. Let's look at the other atom that's going to be involved in this. Chlorine. Okay. Chlorine, Cl, on the periodic table, is in column or group 17. It's in the halogens group, which means it's going to be starting with 7 valence electrons all the way up here. So chlorine is better off gaining 1 valence electron than, trying to lose 7. Okay, so we're kind of going the other direction now. To stabilize as an ion, our chlorine is going to gain 1 valence electron. That way it reaches 8 valence electrons, gets a full set out in that valence energy level, the farthest out reaches of the atom, okay? And that's going to give it a charge. If it's gaining 1 negatively charged electron, it's becoming more negative. And it becomes more and more negative the more electrons it gains. So if we're just gaining 1 negatively charged electron, it's going to have a charge of -1. Okay, so again, nothing new so far. We've got sodium becoming positive and chlorine becoming negative from this give and take of electrons. But let's go back to that question of where they get these electrons. Where does sodium, go throw the electron? Does it just like whoosh, send it off into the darkness, never to be seen again? Or does it go somewhere to be useful? It would be kind of a waste if it didn't get used somehow. What about chlorine? Where is it picking up this valence electron? Well, right now, sodium and chlorine have something in common, right? Sodium has a valence electron it wants to get rid of. It's like, I don't need this thing. What do I do with it? Okay? And chlorine is like, I'm looking for a valence electron. I just need 1 more, and then I can get to 8. I can get that full set. I need that 1 last valence electron. So, when sodium and chlorine get close enough to each other, when they meet up, they have a transfer of that electron. That electron goes from one of those atoms to the other. It goes from sodium to chlorine. Sodium's trying to get rid of its electron. Chlorine's trying to gain an electron. So it's like love at first sight. It's a perfect match. It's a match made in heaven. Or, whatever. So the point is, this works out really well, okay? So, a lot of times atoms don't just, throw away electrons or take them in willy-nilly with no real reason how or why. Typically, that gaining and losing of electrons happens when atoms come together, like this. When they have a mutual benefit, they will both become more stable from this, okay? So, that's what we're going to draw out down here. We're going to show why we make an attractive bond between them. So sodium's looking to get rid of its 1 valence electron, and chlorine is looking to gain it. All right? We want to show how that happens. We want to show where that valence electron goes and what we make in the process. Okay? So we're going to wind up with a positively charged sodium cation and a negatively charged chlorine anion. And we know that positive and negative charges attract each other. They're going to come together, okay? And they're going to attract to each other, and they're going to make a substance. They're going to make a compound, okay? Let's show how it happens. So this is kind of our before. This is before the give and take happens, all right? So sodium started with 1 valence electron. I'm going to show that with a dot. That's sodium's 1 valence electron. It doesn't really matter where you put it. You could put it, at the top like I did, or you could put it over on the right, you could put it on the bottom or the left. It doesn't really matter. I'm going to put it on the top just because I want to. Okay. There's sodium's 1 valence electron. Chlorine started with 7 valence electrons. So we're going to give it 7 dots to show those 7 valence electrons. Now, again, doesn't really matter where I put the dots, as long as I've got 7 of them. Typically, you'll see them kind of given in pairs, like 2 here on the top, 2 here on the right, 2 here on the bottom, and then you'd have 2 here on the left if you had all 8. Again, you don't really have to do that, but that's kind of tradition in chemistry. Electrons tend to kind of pair up when they're in the atom. You kind of get more into the specifics of how those electrons arrange themselves. Now, also keep in mind, we're not showing all the electrons here because not all of them matter. We're only showing the valence electrons because those are the only ones doing the exciting stuff. So sodium doesn't have just one total electron, but the other ones it has are just sitting in closer to the nucleus doing nothing. So we're only showing sodium's 1 valence electron and chlorine's 7 valence electrons. Okay? We said that sodium's got to give up that electron. So what better place to put it than to give it to this chlorine here? Okay, so I'm going to draw an arrow to show that not going over to my chlorine. So sodium is giving that electron over to my chlorine. So this is kind of the before. Okay, this is how we make our ions. On this side, we're going to show the ions that we make and how they stick together, the after of this. Okay, so I go from having sodium with 1 valence electron to sodium with no valence electrons. So I'm showing no dots here. Right? On the other hand, my chlorine had its original 7. 1, 2, 3, 4, 5, 6, 7. Right? And also the one it picked up from sodium. Okay, now, there is no difference between the electrons it usually has versus the electron it just got from sodium. I'm just showing them in different colors so you remember where it came from on the other side here. So this electron moved, and that's the one we're looking at. Okay? They're still just valence electrons, not really any different. What is different is the charge that these ions now have from that give and take. Right? From losing 1 electron, sodium now has a positive charge, a positive 1 charge. And I want to show it. To show that an atom has charge, we'd usually put it in brackets, so these kind of square parentheses like this, and we put the charge up in the top right. So I'm going to put a little +1 for that positive 1 charge. Right? Chlorine is also now an ion. Oops, I'm going to do it in blue. And I'm going to show its charge up in the top right, over here. Okay, so this attraction between the positive sodium cation and the negative chlorine anion is called an ionic bond. It is that attraction between the two. Okay, and the new substance we get because of this attraction is called an ionic compound. Okay, so this guy right here is formed from the attraction between these 2 ions, from that mutual give and take that's made them both more stable, right? And we call that new substance an ionic compound. Okay, let's make some more ionic bonds, but this time we're going to do it between magnesium and chlorine. So chlorine's still there, but magnesium's in there now too instead of sodium, so it might be a little bit different. So let's start off where we did before, with magnesium. So magnesium is going to start with 2 valence electrons. If you go find it on the periodic table, it is in the second group. It's in the alkaline earth metals. Okay, so starts with 2 valence electrons. Which means, like sodium, it's still going to lose those electrons rather than try to gain them. Okay, so the only difference is now it's losing 2 electrons instead of just losing the 1. Okay, so to become a stable ion, our magnesium is going to lose 2 valence electrons to become more stable. It's going to reach 0 valence electrons in the process. It's going to become a cation, a positive ion, and its charge is going to be however many electrons it has lost. That's how positive it becomes. So, lost 2 valence electrons, it's going to have a positive 2 charge. Okay, chlorine's just the same. It starts at 7 valence electrons, wants to get up to 8, so it should gain 1 valence electron. Switch markings. 1 valence electron, right? And it should wind up with a charge of -1, where that 1 valence electron is picked up. Okay, so if we want to show how this ionic bond is formed between these two ions, it's going to take a little bit more work. After all, magnesium's trying to lose 2 valence electrons, but chlorine only needs 1 to become this negative ion. Okay? So it's not like magnesium can just be like, oh, hey, just take 2 of them. Just take 2 of them. Don't worry about it. Don't worry about it. Chlorine's going to be like, well, hey, I need 1 to get to 8 valence electrons. I don't need 9 valence electrons. Don't push that on me. I will take 1 and 1 only. Okay? There's no bartering here. All right? It's got to happen the way it's going to happen. So chlorine's only going to take 1 of those valence electrons off of magnesium's hands, so to speak. So maybe just 1 magnesium and 1 chlorine isn't going to be enough. Let's try to draw this out. So I've got my magnesium here, and it's going to have 2 valence electrons to start with. So I'm giving it 2 dots to show those 2 valence electrons. I'm going to draw my chlorine. And just like before, it's going to start with 7 valence electrons. So we can try something like we did before, where we give our extra electrons magnesium no longer needs over to chlorine. So chlorine has 8 valence electrons now. It's good to go. Check that off. But magnesium still isn't happy yet. It's still got 1 more valence electron to get rid of. So if we can't force it onto this chlorine, what we need is something else to come and take that electron from this magnesium. If we're trying to make a substance that only has magnesium and chlorine in it, well, of the 2, chlorine is the thing that would take the electron. So what we need is another chlorine atom here. It's not just going to be 1 atom of magnesium and 1 atom of chlorine. We're going to need a total of 2 atoms of chlorine. So each chlorine atom is going to start with 7 valence electrons, and each one can take 1 of those valence electrons from magnesium to become stable, to become its own ion. So this magnesium can give its valence electrons to multiple things. It doesn't have to only pair up with 1 ion. Okay? So our magnesium is going to give 1 of its valence electrons to 1 atom of chlorine, and its other valence electron to another atom of chlorine. So both of these chlorines will go from 7 valence electrons to 8. Check those off. And our magnesium is going to give up both of its valence electrons to reach 0. Check that off. Everything's happy here. Everything still works out. Okay? We just needed a couple more of these guys than these guys. All right? We don't always have to have the same number of Mgs and Cls. Okay? So let's show how the charges shake out. When all is said and done, my magnesium should have no valence electrons left. And it should have that positive 2 charge we were talking about earlier. My chlorines should now have 8 total valence electrons. 7. 2, 3, 4, 5, 6, 7. And they've got magnesium's electrons. 8. That's it to 8. All right. And each one of these chlorine ions has a charge of -1. I'll put it up in the top right there. And one over here. Okay, so this is our ionic compound made from the ionic bonds between our magnesium cation that's positive and our chlorine anions that are negative. Now, sometimes it's hard to tell if you've done this right or not afterwards, because what if it was 3 chlorines? Or how do you know for sure that you've done it right? That you've got the right number of Mgs and Cls and things like that. Well, here's a way you can check. Okay, in the end, our positives want to attract to our negatives. Our cations attract to anions. Well, our charges kind of cancel when ions get close to each other. Right? Just like how in an atom, when you have positive protons and negative electrons, you can kind of zoom out, and having the same number of those protons and electrons makes the atom neutral. Same thing goes for when ions get next to each other. When we have a negative and a positive 2 ion all grouped together, those charges kind of cancel also. So altogether, this new compound, this substance made of magnesium and chlorine ions, this marker isn't very good. I'll grab a different one. Altogether, the charge should cancel out, and you should only have atoms that either have 8 valence electrons or 0 valence electrons. They should hit either of those magic numbers. Okay? Chlorine ends with 8 valence electrons. This chlorine also ends with 8 valence electrons. Magnesium ends with 0 valence electrons. So we're on track there. Now also, positive 2 minus 1. Minus 1 leaves us with a charge of 0 for the overall compound. That is a sign of a happy ionic compound as well. So the net charge of all of these ions together in the compound should add up to 0. Okay, now, there's one more thing I'm going to add to this. Okay? As we get further into these problems and they get a little bit trickier, it's going to take a while to get used to how we work these out. Okay? So I want to save you as much time as I can on the things that we've already covered. So figuring out how positive or negative an ion is going to be is something we've already talked about. There's a shortcut on the periodic table, because it only depends on how many valence electrons that we start with and what we're trying to get to. So if you know how many valence electrons something has, you also know what charge it's going to have as an ion, and it's always going to be that way, at least for this class. So if chlorine and fluorine and bromine and iodine are all in the same group with 7 valence electrons, they're always all going to gain just 1 valence electron to reach 8. Which means they're also going to have just a -1 charge. Okay? So rather than trying to do the math in your head and do the kind of mental gymnastics to figure out, okay, well, it's giving, no, it's taking, and then it's negative, so it's taking a negative, so it becomes more negative. Just add it to your periodic table. And the one I have up on Schoology should already have this little shortcut on there. Above the number of valence electrons, you'll see the charge that an ion in that group, in that column, should have. Everything in the first column, the first group, should have a +1 charge. Everything in the second column, the second group, should have a +2 charge. Everything in group 13, the boron group, should have a positive 3 charge. Everything in the carbon group is kind of iffy, but usually we call it positive 4 and just kind of leave it at that. Group 15 stuff usually has a negative 3 charge. Group 16, negative 2. Group 17, negative 1. And our column 18 stuff already has 8 valence electrons typically, so they don't usually form ions. They're going to have a charge of 0.